you have a problem here that you probably should have had some work on. You showed me work on the problems with the binomial formula, but you didn't do any other work. And you might have had this question right if I could have seen your work. Because I think 1 is a root. So let's check. So we have 7x to the 4th, negative 29x cubed, positive 26x squared, negative 7x, and a positive 3. If it is a root, we should get 0 for a remainder. So I bring down the 7. So that's negative 22, which would make this positive 4, which gives us negative 3, which is 0. Okay, so the 1 is a root. Let's see if 3 is also a root. So then we have 7 times 3 is 21, which would be negative 1, times 3 would be negative 3, which would be positive 1, which gives us 0. Now, look at the depressed polynomial. Remember, we started here with to the 4th power. So this would be to the 3rd power. Here's the 2nd power. So we actually have 7x squared minus x plus 1 equals 0. I don't think that factors. So I'm going to use quadratic formula to find the roots. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. A is going to be 7, b is going to be negative 1, and c is going to be 1. So we have the opposite of negative 1, which is 1, plus or minus, and then we'll have 1 squared minus 4 times 7 times c, which is 1. All over 2 times 7, because that's our a. So we get 1 plus or minus 1 minus 28 all over 14. You can simplify that a little bit more. 1 over 14 plus or minus 1 minus 27 would be negative 27 all over 14. Well, it'll be 1/14 plus or minus, if I go over here, I know I have an I, so it'll be I times something. And then, yeah, I don't like to put that square root too close anyway. I'm going to make a factor tree for 27. And you know, 27 is the square root of 9 times the square root of 3, so it's 3 radical 3. So you have I'm going to say 3i square roots of 3 all over 14. Looks like you forgot the 1/14th, because I think you had the rest of it. You had the plus or minus kind of weird too in your problem, but you forgot the 1/14th. Otherwise, I think you would have had this right. If we take a look at this problem, we want to use the factor theorem. So in other words, you use synthetic division. I want to know, is x minus 3 a factor? And then find the remainder. So let's do this. Let's find it when 3. So we have 2x to the 4th, positive 4x cubed, negative 4x squared. Notice we don't have an x term, so I'll say 0x and a positive 9. So bring down the 2 times 3 is 6, plus 4 is 10, which is 30, which gives me negative 26. Ooh, this is kind of ugly, isn't it? 4, 3, 2, yep. And then 3 times negative 26 would be what? Negative, and let's use a calculator. Looks like I lost my calculator. 3 times 26, for some reason, my mind wants to say 72, but I don't think that's right. 78, there we go. So then we get negative 78. Negative 78 times 3 gives us negative 234. I'm going to double check my work here real quick because I don't want to make a mistake. So 2 times 3 is 6. 6. Oh, there we go. Dang it. It just seemed really big for what we're doing because it was a negative 4 here, wasn't it? Negative 2x to the fourth, negative 4x cubed, negative 4x squared, 0x, and 9. Let's try that again. So 2 times 3 is 6. That'll be a positive 2. Times 3 is 6 again, which gives me positive 2 again. Times 3 is 6. 6 times 3 is 18, so I get 27. So P of 3 is 27. It's not a factor because the only time it would be a factor is if you got 0 for an answer. So this one is not a factor because it equals 27. Okay, for the polynomial below, negative 3 is a 0. I want to express as a product of linear factors. Okay, so here's what we're going to do. First, we're going to find negative 3 because we know it's a 0. So 1x cubed, negative 3x squared, negative 14x, positive 12. I know I'm going to get 0 here. So bring down the 1 times negative 3 is negative 3, which gives me negative 6. Times negative 3 is positive 18, which gives me 4. Times negative 3 is negative 12. Now this is squared term, so I've got x squared my pen, hopefully my pen isn't dying. There we go. So we get x squared minus 6x plus 4 equals 0. I cannot find two numbers that multiply to 4 and add to negative 6. So I go x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So then I'm going to say the opposite of b. So remember, a is 1, b is negative 6, and c is 4. So the opposite of negative 6 is positive 6, plus or minus the square root of 36, because that's b squared, minus 4 times 1 times 4, all over 2 times 1. So I get 6 over 2 plus or minus 36 plus 16 all over 2. Well, let's simplify 36 plus 16. (36 plus 16 is 52. I can simplify the square root of 52 over here. That is 4 goes into 52 how many times? 13 times. So we get 2 square roots of 13. Which now I can reduce the 2, so I get 3 plus or minus 2 square roots of 13. Not 2 square roots of 13, but the square root of 13, because the 2 is reduced. So now let's write it as a product of linear factors, because we know negative 3 is a root. So it'll be x minus 3 times x minus 3 plus the square root of 13 and x minus 3 minus the square root of 13. Guess we could distribute that negative sign. We'll have x minus 3 times x minus 3 minus the square root of 13 and x minus 3 plus the square root of 13. Actually, I like this answer better because that's easier to see the linear factors. Both are correct. Okay, this one you had some of them right, but you had other roots in here that were not true. The factors of p over the factors of q. Well, the factors of 3 are plus or minus 1 and plus or minus 3. The factors of q are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Now p over q, well, it'll be plus or minus 1, plus or minus 3, plus or minus 1/2, plus or minus 3/2, plus or minus 1/3, but 3 over 3 is 1, so you don't have to rewrite that again, plus or minus 1/6, plus or minus 2/6, which would be 1/3, which you already have, or 3/6, which would be 1/2, which you already have. These are all your roots. Notice, we don't have a 2 in there. So you had that 2 in there that which is not correct. You didn't have 6. Did you do q over p by chance? Thinking that's what you did instead of p over q. Okay, dividing a polynomial p of x by x plus 1 yields a quotient with remainder of 4. So if I write this out, p of x divided by x plus 1 equals our quotient polynomial with the remainder of 4. So I'll put plus 4 on there. Or, instead of thinking of it as a division problem, think of it as a multiplication problem. In other words, p of x equals x plus 1 times q of x, I don't know why I put parentheses around the q, plus 4. Now we're supposed to find, we're told q of negative 1 is 4. We're supposed to find p of negative 1. Let's start there. So p of negative 1 equals negative 1 plus 1 times q of negative 1 plus 4. Well, as it turns out, negative 1 plus 1 is 0, isn't it? If we multiply that by q of negative 1 plus 4, anything times 0 is 0, so our answer is 4. So p of negative 1 equals 4. We're also supposed to find p of positive 1. So p of 1 equals 1 plus 1 times q of 1 plus 4. Well, 1 plus 1 is 2. From our directions, q of 1 is negative 4. We'll add 4 onto that. So 2 times negative 4 is negative 8, plus 4 is negative 4. So p of 1 is negative 4. That's how you should approach that problem. Now on this one, we want to find a polynomial of degree 3 with these coefficients in the zeros. Well, remember, if you have a complex root, its conjugate is also a root. So the conjugate is also 3 plus I. That's also a root. So in other words, we're going to say x minus a negative 1 times x minus 3 minus I and x minus 3 plus I. Let's simplify that a bit. So that's x plus 1 times x minus 3 minus I Try that again. X, whoops, wrong one. X minus 3 plus I and x minus 3 minus I. Let me show you a different way of multiplying this since we're getting this wrong. I'm going to think of my next two terms. I'm going to leave the x plus 1 alone for now. But I'm going to think of this as x minus 3 plus I and x minus 3 minus I. That's a difference of squares, isn't it? So this is actually x minus 3 squared minus I squared. Well, let's do that. Well, x minus 3 squared, well, that's x squared minus 6x plus 9. And then when I square I, that I squared is -1, so I've actually got plus 1. So now this actually simplifies to x squared minus 6x plus 10. And then we'll multiply it by x plus 1. Still use the rectangle for when I got 3 by 2. Just showing you an alternate way of doing the first one. So you got x squared minus 6x and then plus 10. We're going to multiply that by x plus 1. So we get x cubed minus 6x squared plus 10x. And then we just have x squared minus 6x plus 10. So when I multiply those together, I combine my like terms, we have x cubed minus 5x squared, because you're taking -6 plus 1. And then if I take 10 minus 6, I get positive 4x. So plus 4x plus 10. That polynomial will have those roots. So f of x equals x cubed minus 5x squared plus 4x plus 10. Okay, on this one, we want to find all, once again, if I would have seen you work, I could have seen what's going on here because you got part of it right. So let's do 1. We have 5x to the 4th minus 14x to the 3rd, positive 6x squared, positive 5x minus 2. I know I should get 0 here. So bring down the 5, you get 5. Negative 14 plus 5 is -9. 6 minus 9 is -3. 5 minus 3 is 2, and you get 0. Now let's do 2. So bring down the 5. 5 times 2 is 10, which gives us 1 times 2 is 2, which is -1, -2, which gives us 0. Then what we have here is we have 5x squared plus x minus 1 equals 0. And I don't think that factors like what you got, because I can't find two numbers that multiply to -5 and add to 1. So at this point, I'm going to use my quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. A is 5, b is 1, and c is -1. So we're going to have the opposite of 1 plus or minus b squared, which is 1, minus 4 times 5 times -1. All over 2 times 5. So let's simplify that now. So I'll get -1 over 10 plus or minus. And then if we go 5 times 4 is 20. So it'll be 1 plus 20 all over 10, which simplifies to negative 1/10 plus or minus the square root of 21 all over 10. The square root of 21 does not simplify, so there's your answer. Those are your two roots you should have gotten, not 2/5 and negative 3/5. Finally, we're going to divide these. Since we're dividing by just one term, I think I'm going to write it as a fraction. So we have 12 z to the 5th, u to the 5th, all over negative 3 z cubed u to the 4th, minus 26 z squared u to the 5th. Oops, my pen died. Give me a second here. U to the 5th, all over negative 3z cubed u to the 4th. Keeps on dying here. Hopefully I can get through this review with you. Okay, now let's divide. 12 divided by negative 3 is negative 4. Subtract your exponents. 5 minus 3 is z squared. U to the 5th. My 4 didn't show up there. U to the 5th over u to the 4th is u to the 1st. So we're good there. A negative divided by negative is a positive. 26 and 3 do not reduce. So I'm going to put it over 26 and 3. Z squared over z cubed would be z to the negative 1. 5 minus 4 is u to the 1st. So then we get negative 4 z squared u plus, let's flip the negative exponent. So we get 26 over 3z, 26u over 3z, and there's your answer. Don't know what you did wrong to get that question wrong. Okay, the